Good morning, dear students. Today we are going to discuss about oxidase test. I already put a video on that, but I felt that this needs more explanation, so I made a better PPT. So let's start discussing. So the oxidase test is a pivotal tool in microbiology, essential for different bacteria species based upon the cytochrome C oxidase activity. This presentation will divide into the history, purpose, and the theoretical underpinnings of this test. We'll explore the various methodologies, safety considerations, and practical tips for accurate results. Understanding the oxidase test is crucial for the microbiology students and lab technicians alike, contributing to the precise bacterial identification and diagnosis. So, history. Early discoveries. The concept of testing for oxidase system originated in 1928, pioneered by Gordon and MacLeod. They utilized a dimethyl p-phenyl diamine dihydrochloride solution to distinguish Neisseria gonorrhoeae from Staphylococcus and Streptococcus species. And it was enhanced by Kovacs. Kovacs later enhanced this test by a tetramethyl p-phenyl diamine dihydrochloride solution, adding to a quicker reaction. The innovation marked a significant advancement in an oxidase test method. Gaby and Hadley's contribution. Gaby and Hadley further refined this oxidase test by incorporating a amino dimethylaniline oxalate and alpha naphthol. This modification enabled the detection of oxidase test in tube cultures, expanding the test's application. Purpose. So the primary objective of oxidase test is detection of the presence of cytochrome oxidase, an enzyme vital for bacterial respiration. This enzyme is also known as iodo-phenol oxidase, facilitates the transfer of electrons to oxygen. The oxygen transport chain. The electron transport chain is an integral bacterial respiration. Cytochrome oxidase catalyzes the oxidation of cytochrome C while reducing the oxygen to water, representing a critical step in energy production. Reagent oxidation. This test utilizes a reagent like tetramethyl phenyl diamine dihydrochloride, an artificial electron donor. Upon oxidation by cytochrome C, the reagent transitions from a colorless to dark blue or purple compound known as iodo-phenol blue. Mechanisms. First is electron transfer. In bacteria possessing cytochrome oxidase, each of the 4 cytochrome C molecules transfer one electron to the enzyme. This initiates the subsequent steps in oxidase production. Next is the electron-rich system. Following the electron transfer, the cytochrome oxidase enzyme becomes electron-rich. This state is crucial for the final step of respiration, water formation. As accumulation of respiration, the cytochrome oxidase enzyme transfers 4 electrons to the molecular oxygen and 4 protons. This results in the formation of 2 molecules of water. TMPD interaction. The tetramethyl p-phenyl diamine dihydrochloride molecule donates an electron to the electron-poor cytochrome C, becoming an electron-poor radical. So, oxidase reaction and reagent preparation. First is oxidase TMPD. When TMPD is oxidized, it turns into dark blue, thus indicating the positive result. Organisms can also be classified as variable and delayed oxidase positive. Variable reaction in oxidase can be a result of differences in the cytochrome C composition, variability in the cytochrome oxidase and transport chain composition. Kovacs reagent. To prepare Kovacs reagent, mix 1% of tetramethyl p-phenyl diamine dihydrochloride in water. Store refrigerated in a dark bottle for not more than 1 week. Gordon MacLeod's reaction. For Gordon and MacLeod's reaction, combine 1% dimethyl p-phenyl diamine dihydrochloride in water. Like wax resin, store in refrigerated dark bottle for not more than 1 week. Oxidase test variations and filter paper method. Gaby and Hadley's reagent. Prepare Gaby and Hadley's reagent by mixing 1% of alpha naphthol in 95% of ethanol and 1% of p-amino dimethyl allyl oxalate. Store refrigerated in a dark bottle for up to 1 week. Commercial reagents. Oxidase reagent can be bought in droppers, impregnated discs, and test strips. Ensure that they are according to the manufacturer's instruction. Filter paper test. In the filter paper test, soak pieces of filter paper in 1% of coax oxidase reagent. Let them dry, then rub the colony with a fresh culture. Observe for color change. Spot and direct plate oxidase test method. So for the spot method, pick a colony, rub it on the filter paper and add 1 to 2 drops of 1% coax reagent. A dark purple color will appear in around 5 to 10 seconds, indicates a positive result. Direct plate method. In this method, grow bacteria or nutrient agar, then add 1 to 2 drops of coax or Gordon's or McLeod's reagent. Observe for the color change as with the spot test. So the timing. The microorganisms are considered to be oxidase positive only if the dark purple color is obtained within 5 to 10 seconds with coax reagent, or oxidase negative if no color change occurs in 2 minutes. Next is tube method. So tube test method. So here the bacteria is grown in nutrient broth, add alpha naphthol and p amino dimethyl aniline oxalate. A blue color change within 15 to 30 seconds signifies the positive result. Reaction time. With Gordon and McLeod's reaction, positive oxidase test reaction show red within 10 to 30 minutes or black within 60 minutes. Absence of color change indicates negative results. Delayed reaction. Delayed reaction may show purple color within 2 or 3 minutes, indicating variability in oxidase activity within the test organism. Safety precautions. So adhere to the lab safety techniques is paramount. Consult ASM guidelines for biosafety in teaching laboratories. Fresh reagents are crucial for oxidase test. Reagents are auto oxidase. Reagent freshness. Reagent should not be older than 1 week. Steel found in auto oxidation can be shot by 1% ascorbic acid. Insert loop. Nickel, steel or white loops may yield false positive. Use platinum insert transfer loops, sterile loop sticks, sterile plastic sticks or sterile toothpicks. So media consideration and best practices. Sugar content. High glucose levels inhibit oxidase activity, so it is recommended to test colonies growing on media without excess sugar like nutrient agar, triticus soy agar, which are also excellent media. Dyes. Bacteria growing on media containing dyes may give aberrant results, so older cultures are less metabolically active and they are undesirable or unreliable for this test in a clinical setting. Microorganism viability. The reagents will effectively kill the microorganisms, so subculturing should be done before adding the reagent to the active culture. If older cultures are there, you should expect longer reaction time.